methodology for creating a suite that contains a variety of options for improving the building envelope. This is going to be an additive suite, so you'll be adding one after the other in order to understand and analyze the synergies that different measures have with each other. Start by downloading the Energy Dashboard version 2. This version fixes a couple errors that were in the old dashboard, and it adds a sheet that gives you an example for this optimization suite. In this suite, you can see that I've got a baseline, which is the best representation of the existing building that I have as a model. And then it adds building improvements to that. First wall insulation, then triple glazing, infiltration control, et cetera, et cetera. For every building, every climate, this is going to be different. And I expect you to develop at least one set of options that you'll be able to sort of build up. You can see up here in the inputs, instead of using this as you did for the elimination parametric sensitivity analysis, now we're going to use the same format in order to understand what it is that we're adding for each run. So for instance, the baseline is the baseline, and then we're adding 300 millimeters of exterior wall insulation. Then we're adding passive solar glazing. Then we're adding infiltration control, et cetera, et cetera. Another thing to note here is that I'm going to ask you to take this input-output summary that's already in your dashboard and change it in order to create the optimization suites. In this case, we're not interested in the benchmark or the energy estimate. We're going to start from the baseline and then work our way across in order to better understand how changes to that baseline model will affect performance. The best way to go about this is probably to just copy this sheet. You can do it this way by creating a copy, and I like to put it right after the input-output. If you get this message, you can click yes. In fact, click yes to all of those things, and then it will copy that input-output summary right next to it. And so now I could call this the optimization suite A, in case you want to do extra suites. And the first thing I'll do is delete the benchmark, delete the energy estimate column, and you'll begin populating the baseline. Notice when I deleted those columns, it deleted the columns that were in this graph as well as the columns down here. So everything is still nice and concise, and we can read it fairly easily. Likewise, if you ever want to add a column, you click in here and right-click and insert, and it will insert a column. It also inserts one in the graph. So you see here, if I rename this 02 daylighting, then it's going to add that right to the graph. So that's a nice kind of interactive feature of this. So instead of having these be elimination parametrics now, I'd like you to customize it and make your own suite. And so I would start with just white cells here, and I can make those by copying and pasting them over. And then as you make changes to the baseline, highlight them so you'll know what's changed more obviously. So starting out here, I'd like you to begin with the baseline building that has in it whatever optimized mixed mode operation you found. And this should reflect how the building's actually operated. Actually, if it doesn't have mixed mode operation, then don't include it. But if it does have ventilation, natural ventilation, or economizer mode in the actual building, then that is going to better approximate how the building actually functions, and I'd like you to use that now as a new baseline. So I've taken my the mixed mode operation baseline that I developed in the last tutorial, and I've renamed it as 30 baseline 02, and I'm going to open that in the IDF editor. And before I actually go through this, what I'd like you to do in developing at least two different suites of improvements is to first take a step back and discuss as a team the fundamental strategies you think will improve the building performance. And
This is going to involve really using your brain. It should be a really fun exercise, I hope. And sometimes I find that it helps to sketch through different options, to have a plan or an elevation and consider what the building will look like with the different options. In the Drive folder, I've included an example for you to show the type of analysis I'm looking for here. This is a former student of mine. Actually, instead of just doing 2 suites, they did 5 suites. But they took their base building and then imagined what it would be like with different types of constructions and different assemblies, thinking about their base building and what it represents, and then changing it to be more like a thermos, more like a combination greenhouse thermos pyramid, and then also looking at some different materials, straw bale, shading and glazing and ventilation. They did a very nice job of representing both what the existing conditions are like. Here's a typical wall section, for instance, and here's how it functions, both in terms of comfort and energy. And then if we add more insulation, here's aesthetically what the differences are, how it feels to be in it, how things change, how the envelope reacts. And so I would encourage you to think about your model in these terms. So if I'm taking Worcester 214, for instance, I would start by discussing with my team, what is the building like now, as we did in class. We sort of came to the conclusion that it's kind of a ventilated pyramid. And then how could it perform better? So one idea is that what if we insulated it? What if it were more like a thermos? So it was kind of like a ventilated pyramid thermos. Which would entail a few things. One would be increasing the insulation. Another would be possibly improving the glazing. Another would be to weatherproof the envelope so that there's less infiltration. And maybe we could also improve the fan performance by using heat recovery fans or just using fans that are localized. I'll just say localized fans here. So there's less leakage through the ducts. So that would be sort of a few things that are envelope related. There's probably also a good amount that are internal load related. So we could probably reduce the lighting energy and probably the equipment energy by installing better appliances and computers. We know already that heating is a big deal for Worcester, and so probably improving the heating performance, heating system would also be helpful. What I'd like you to do is kind of build up this suite, write it down, and then approach modeling it. The way that I'd like you to model this is to take your baseline, and then in the last set of analyses, you took, in sensitivity analysis, you took one at a time and tested each one. In this case, though, what I'd like you to do is test it cumulatively. So we're going to kind of step through each of these improvements and keep sort of improving them one based on the last model. Let's start inputting now, actually, what my specific improvements will be. I'm going to add a foot of insulation, so 300 millimeters. I'm going to enter this under my exterior walls here. Oh, here's a tip, by the way. If this is sliding down and you can't see anymore what's up there, you can highlight the row that you want to be able to see, click View, and then click Split. This will introduce these panels that you can move like so. And now I can make sure I'm always seeing that top row and this side row as I scroll across. Sorry, I've got 300 millimeters of added insulation. I'm also going to add some, for the windows, some passive solar glazing, so probably triple glaze with a pyrolytic coating. I'm going to improve my infiltration by adding weatherproofing, both weatherizing the envelope and around the windows. I'm going to simulate localized fans by eliminating ducts. That's going to be reflected in my fan pressure rise or pressure loss. For the lights, I'm going to add LED lights, and then I'm also going to add Energy Star equipment here in my equipment category. And last one, for the heating system, I'm going to do a relatively large retrofit here and install heat pump radiators. So I'm going to dramatically improve my heating coefficient of performance that way. So these are the changes I'd like to make.
In the next tutorial, I'll show you how fast and easy this can be to model quickly in Energy Plus.